Hello and welcome to this demonstration of LP-Solve. In this video, we'll look at infeasible solutions, what causes them, and how to resolve them. An infeasible solution occurs when there is no combination of ingredients that can satisfy all of the constraints at the same time. In other words, the requirements you've set are mathematically impossible to meet. Let's start with a very simple example. I'll create a ration with just two ingredients, dried corn grain and lard. Corn is priced at $175 per metric ton, and fat is priced at $450 per metric ton. The nutrient values you see come directly from the feed library. If I set a minimum dry matter of 88% and run the formulation, LP-Solve finds a feasible solution, about 91% corn and 9% fat. That combination allows the ration to meet the dry matter requirement. Now let's change the constraint. Instead of a minimum, I'll set a maximum dry matter of 85%. Both corn and fat have dry matter values greater than 85%. That means no matter how I combine them, there is no way to meet this requirement. As a result, the solver returns an infeasible solution. In LP-Solve, this is reported as code 0. Next, I'll remove the dry matter constraint and set a minimum crude protein of 12%. Again, neither corn nor fat contains enough protein to meet that requirement, so again, there is no feasible solution. If I lower the protein minimum to 8.5%, the solver finds a feasible solution using 100% corn. Now let's combine constraints. I'll set a dry matter minimum of 88% and a crude protein minimum of 8.5%. To meet the protein requirement, the ration must be 100% corn. But corn has a dry matter of only 86.9%, so it fails the dry matter requirement. These two constraints conflict and the solution becomes infeasible. If I reduce the dry matter minimum to 86%, the solution becomes feasible again. This illustrates an important point. Infeasible solutions often result from the interaction of constraints, not from any single requirement. Now I'll add an ingredient constraint and limit corn to a maximum of 50%. To meet protein and dry matter, the solver still needs 100% corn, but that violates the ingredient maximum, so the solution is again infeasible. If I remove the protein requirement and keep only a dry matter minimum of 86%, along with 50% maximum for corn, the solver finds a feasible solution, 50% corn and 50% fat. However, that ration contains only about 4% crude protein, which may not be nutritionally acceptable. Now let's expand the ration to include a few more typical ingredients. I'll add soybean meal, 48% protein, barley grain, and calcium carbonate. Soybean meal is priced at $500 per metric ton, barley at $200, and calcium carbonate at $45. If I set only a dry matter minimum of 86%, the solver selects 100% calcium carbonate. It's the least expensive ingredient and easily meets the dry matter requirement, even though it provides no protein or fat. To make the ration more realistic, I'll add a crude protein minimum of 16% and a fat minimum of 3%, along with the dry matter minimum. When I run the formulation, I get a feasible solution. Dry matter is well above the minimum, protein is exactly 16%. One of the most common causes of infeasible solutions is over-constraining the formula. For example, if I set both a minimum and a maximum dry matter of 86%, I eliminate nearly all possible ingredient combinations, and the solver returns an infeasible solution. Another common mistake is setting the maximum that is lower than the minimum. This always results in an infeasible solution because the allowed range is inverted. Ingredient limits can also cause problems. If I restrict soybean meal to a maximum of 3%, the remaining ingredients cannot supply enough protein to meet the 16% requirement, and the solution becomes infeasible. Similarly, forcing an ingredient to an exact inclusion by setting the minimum and maximum to the same value can eliminate all feasible solutions. Let's look at one final example. I'll set a dry matter minimum of 86% and a maximum of 89%, along with a protein minimum of 16% and fat minimum of 3%. This formulation solves successfully. Now I'll add a phosphorus minimum of 0.7%. When I rerun the formula, the solution becomes infeasible. The only way to meet the phosphorus requirement is by increasing the soybean meal. However, soybean meal has a dry matter of 89.3%, which exceeds the dry matter maximum. These two constraints conflict, and the solver can't resolve them. Every time we add a minimum or maximum, we reduce the solution space. As more constraints are added, that solution space becomes smaller and smaller until eventually no feasible solutions remain. When you encounter an infeasible solution, the best approach is systematic troubleshooting. Remove constraints one at a time until the formulation becomes feasible again. This process helps identify which requirement or combination of requirements is causing the problem. Well, that's it for this demonstration. Be sure to visit the LPsolve knowledge base for more examples and guidance on using the software. And thanks for watching.